Hello everyone, welcome back to my sessions. In today's session, we will be discussing about chained matrix multiplication. This is one of the most requested video. So out of the box, I'm doing this. Okay, so in this one session, we will be learning about the algorithm for chain matrix multiplication. Before to that, we will see one solved example and we will also discuss the time complexity of this. And this is from the subject design and analysis of algorithms. And for some students, it is analysis and design of algorithms. Let it be DA or ADA, anything is same. Okay, so we are discussing unit 4, which is dynamic programming. Okay, let's get into the details. First, let us see what is chained matrix multiplication. The aim of this problem is you will be given a set of matrices. Say suppose a sequence of matrices A1, A2, A3, so on, AN. Our aim is to find out the best order in which if I multiply, the number of multiplications will be minimized. What do I mean? For example, there are a sequence of matrices A1, A2, A3. So in which order should I multiply? Should I first multiply A1 with A2 and then in sequence with A3 and then the result with A4 and then the result with A5, so on up to AN? Is it the only way to do? No. I can multiply the matrices in any order because matrix multiplication is associative. The final result is going to be the same. So now what am I supposed to do? I can change the order of multiplication. Instead of multiplying A1 with A2, I can multiply A1 with A3. Okay, provided if it is compatible. Okay, and while doing so, okay, I want to reduce the number of multiplications. Let us see one example. Before to that, let us see how to calculate the cost of multiplying. So for example, let me take a 2 by 2 matrix. Okay, so 1, 2, 3, 4. The order of this is 2 by 2. And let me also, for simplicity, I'll take a 1 by 2 matrix, which is 3, 4. Okay, see the order of this, you can see. Okay, so in order to multiply or in order to get one element, how many multiplications you should do? Just let us try to recollect the process of multiplication. Okay, so for matrix multiplication, first of all, we need to check the compatibility. What is the compatibility rule? The number of columns in first matrix should match with the number of rows in the second matrix. Yes, here it is matching. Okay, so here we are taking it as P cross Q and this we are taking it as Q cross R. So here it is Q and Q. So that means it is compatible. 2 and 2, it is compatible. What will be the result? The result will be a matrix of order P by R. So here it is 2 by 2 and this is 2 by 1. So the resultant matrix will be of size 2 by 1. And in order to get the first element, okay, so in this 2 by 1 matrix, in order to get the first element, how do I get? I have to multiply this row with this 2 elements in this particular column, right? So that is 1 into 3 plus 2 into 4. How many multiplications am I doing? 2. Similarly, in order to get the second element also, I need to perform the same. So that means I am performing Q number of multiplications. Forget about additions. We are talking only about the number of multiplications. Okay. So I am performing Q number of multiplications in between. So the overall cost of this matrix will be P into Q into R. So here it is 2 into 2 into 1. Okay, so this we are calling as the cost of the matrix. Now let us take one more numerical. So where here you have a matrix A1 which is of order 10 cross 100. The second matrix which is of order 100 cross 5. And the third matrix is of order 5 cross 50. Okay. So here if you observe 5 and 5 matching. So either I can multiply A2 with A3. And here you can see A1 100 and 100 and matching. So I can multiply A1 with A2. It is my choice. I can change the order and I see in which order I get minimal number of multiplications. Let's proceed. Okay. So taking the above example into considerations, if I first multiply A1 with A2. Okay. So what are the total number of multiplications? 10 into 100 into 5. And then the resultant matrix order will be 10 cross 5, right? So this I need to multiply with A3, which is of order 5 cross 50. So what will be the number of multiplications? It is 10 into 5 into 50. So the total number of multiplications are 7,500. Now let us take one more possibility. That is, first let us multiply A2 with A3 and then let's multiply with A1. So if I multiply A2 with A3, okay. So here you can see the total number of multiplications are 100 into 5 into 50, 100 into 5 into 50. The resultant matrix will be of order 100 cross 50. So that I need to multiply with the resultant matrix. From these two, the resultant matrix will be of size 100 cross 50. This I need to multiply it with A1. Okay. So I will be getting 10 into 50 into 100. So overall multiplications you can see 75,000 multiplications. So which one will be a better choice? This one will be a better choice. So this is what the exact task that we will be going to do in chain matrix multiplication. Here we have taken only 3. So manually I'm checking which one will be a better option. Okay. Given n number of matrices. Okay. How to choose this particular order is the concept of chain matrix multiplication. Okay. So before discussing the algorithm, let's solve one example. One numerical we'll do and then we discuss the algorithm. Okay. So to start with the numerical, you will be given matrices directly or sometimes they might be giving a sequence in exam. Suppose if they give the matrices like this, it is fine. Okay. So here you can check whether the compatibility is matching or not. So and from this you need to formulate a sequence. Okay. So how do we formulate that sequence is, here you can see 4 and the number whatever is repeating for the compatibility checking, this and this we will check, right? So this you need to write only once. So 4, 10. Again in the next two matrices 3 and 3 is repeating, just write only once 3. And in the next 12 and 12 is repeating, write only once. 20 and 20 repeating, write only once. And then write the last number of columns, which is 7. So the final sequence that you will be getting is this one. Okay. So if they give sequence also, you need to formulate the order. How do we formulate? What will be the order of the first matrix? It will be 4 cross 10. Second matrix will be of order 10 cross 3. Third matrix will be of order 3 cross 12. Fourth matrix will be of order 12 cross 20. Fifth matrix will be of order 20 cross 7. Okay. So given in any way, you might be able to solve. So this is first foremost important point. Otherwise, you will be stuck at this moment itself. Okay, sometimes they will be giving you a sequence or sometimes they might be giving you this matrix order. Okay, so given anything, you should be able to formulate both the ways. Okay, so now let's see the procedure. So before going to that, let us understand the vocabulary. So in general, given any matrix, we call it, let us call it as AI. The order of this, we are considering it as P of I minus 1 into Pi. So that means taken any matrix AI, the order of this, we are taking it as Pi minus 1 multiplied with Pi. Okay, done. Next, what is our aim? We want to compute the minimal number of multiplications, which we are indicating with M of I comma J. And we want to compute M of 1 comma N. So starting from the first matrix A1 to AN, the last matrix, what are the minimal number of multiplications? So for that, under any dynamic programming concept, we have a recursive formula, right? So here the recursive formula that we will be using is M of I comma J is 0 whenever I is equals to J. Otherwise, it is minimum of I less than or equals to J. It is not 1, it is I. I less than or equals to K less than J. M of I comma K plus M of K plus 1 comma J plus P of I minus 1 into P of K into P of J. Okay. You will understand this when we solve an example. For the numerical, I'll take the same sequence. Forget about what are the numbers inside the matrices. We are worried about only the order. Okay, so I'm taking the sequence directly. And I also explained you given matrices how to write the sequence also. So here is the formula, and here we need to formulate a matrix. Okay, so matrix multiplication, right? So we will formulate a table. So totally how many matrices we have? So totally 5, right? So we need to formulate a 5 cross 5 table. Okay. So only it is important to know how many matrices are there and how to write the order of this. And here in this sequence, we will denote this as P0, this one as P1, this 3 as P2, this is P3, this is P4, and this is P5 in the sequence. So here we need to know what is this I minus 1, K and J, right? So in this sequence, let us treat it as an array index starting with 0. Okay, the first one is P0, P1, P2, P3, P4, and P5. Okay, so in any two-dimensional array, okay, we have rows and we also have columns. And here our row number is starting with 1. Even our column number is also starting with 1. Okay, so this first element will be 1, 1. This is 1, 2, 1, 3, 1, 4, 1, 5. This is 2, 1. This is 2, 2. This is 2, 3, 2, 4, 2, 5. Okay. Similarly, we will just number. And here if you see, m of ij value is equals to 0 wherever I is equals to j. So all 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 will be 0. So only I made this diagonal to 0. So this is a diagonal matrix. So the lower triangular matrix will be similar to the upper triangular matrix. So you need not compute all the values. Okay, so we will compute only the upper triangle and the other one will follow symmetry. Okay, fine. So now the first value that we need to compute is for 1, 2. Okay, so first we will compute m of 1, 2. So here this is I and this is j. I need to choose a k which will be in between these two values. Okay, k can be equal to I. So k value can be equal to 1, but it should be less than 2. So that means this one we will be solving for only one value of k, that is 1. Okay, so just let us try to substitute. I is 1, k is also 1, m of 1, 1, k plus 1, k is 1, so k plus 1 will be 2, j is 2 plus I minus 1, I is 1, so I minus 1 will be 0. Then p of k, which is 1, and p of j value is 2. So p0 multiplied with p1 multiplied with p2. Let's substitute these values from this particular table. So already we know the value of m of 1, 1. Okay, so which is 0. And similarly m of 2, 2 is also 0. Okay, so 0 plus 0, p0 value. So from this sequence, the first value is p0, which is 4, multiplied with p1, the second value, which is 10, multiplied with p2, which is the third value. So you will be getting a result of 120. Similarly, let's compute for m2, 3. Okay, so here k can be equal to I, but it should be less than j. So only we will be solving for one value of k, which is 2. Okay, so just substitute in this formula. You will be getting m of 2, 2 plus m of 3, 3 plus p1 into p2 into p3. So from here, 2 value is 0, 3 value is also 0. So we'll just multiply p1, which is 10, with p2, which is 3, with p3, which is 12. Okay, so which we are 10 into 3 into 12, which is 360. Similarly, we will compute 3, 4 value. Okay, so that we are getting as 720, and we also compute 4, 5 value, which we are going to get as 1680. Okay, so let's update this table now. The first step is done. Okay, so let's update this table. I have updated the table with this value. What is our aim? My aim is to compute this particular value, m of 1, 5. In order to compute that, I should know these values. In order to know these values, I should know the values of this. Again, in order to know this, I should know this. Okay, so this is what we do in dynamic programming, right? So we follow a recursive procedure. So I'm starting from the base, which is this 1, 2, 2, 3, 3, 4, 4, 5. I have solved these values. Now, let's proceed for the next values, which are 1, 3, 2, 4, and 3, 5. Let's compute. So here, for your convenience, I have taken the result of previous step. And again, I'm giving you the formula also. Okay, only one step I will explain. The rest all will follow the symmetry. Okay, so here I am solving for m of 1, 3. So what will be my k value? My k value can be equal to 1, but it should be less than 3. So what will be my k? It will be k will be 1, 2. Yes. So k value can be 1 and it can be 2 because it should be less than 3. So now I am getting two values. Out of these two, whichever is minimum, that I need to take. In a previous step, I got only one k value. So in that, there is no minimum. Whatever I got, that is minimum. But here I have two possibilities. Okay, so just this first step is for k is equals to 1 and this is for k is equals to 2. I comma k, 1 comma 1, k plus 1 is 2 comma 3. Okay, I minus 1, which is 0, k is 1 here, and pj is 3. This is I, and this is j. Next, this is for k is equals to 2. So I comma k, I is 1, k is 2, k plus 1, which is 3, j is 3. Then p naught, I minus 1 is p naught, k is 2, j is 3. So if you substitute these values, okay, so these values we already have. So 2, 3 value I have in this table. This is the value of 2, 3 and this is the value of 1, 2. So this I will just substitute it here and I will take the minimum value. So the minimum value among 840 and 264 is 264 and this I got for a value of k equals to 2. Okay, so noting down this k value is also important. We do this at every step. Similarly, let's calculate for 2, 4. Okay, so here k can range between, this is our I and this is our j. So your k can range from 2 to 3. So k value can be 2, 3 because it should be less than 4. Okay, so similarly I have substituted. So this first one is for k is equals to 2 and this is for k is equals to 3. And if you substitute the values, okay, so 3, 4 value we have here in the table. This is the value for 3, 4 and 2, 3 value also we have in the table. So this is the value for 2, 3. Let us just substitute those values. And if you multiply P0, P2, P4, P1, P3, P4, so you are getting these two values. So in this step, the minimum is 1, 3, 2, 0. Again that I got for k is equals to 2. Similarly, we'll calculate for 3, 5 and here this is the result 1932 1140. Minimum is 1140. So this I got for k is equals to 4. So here k values are for 3 and 4. So this first one is for k is equals to 3 and this second one is k is equals to 4. So we got a minimum value of 1140 for k is equals to 4. Okay, so that we have noted down. And let's also update this table. Okay, I just updated this table with the values that we have computed. So in the next step, we need to compute for M14 and M25. Okay, so for M14, what could be the k values? By this time, you should be able to find out what should be the k values. K can be 1, 2, and 3. So you will be getting 3 values out of the 3, whichever is minimum that we will be taking. Okay, so the first one is for k is equals to 1 and this is for k is equals to 2 and one more, this is for k is equals to 3. So these are the values that we are getting. All the time we will be using the values which are there in the table. So only I'm giving you this table every time. So here M24 value. So already I have it here. M24 is 1320 and M34 also we have in the table, which is 720 and M13 also we have, M12 also we have. So all these values we will be taking from this table. And if you substitute, okay, so these are the values that we are getting. And Among this, the minimal value is 1080. So this we got for k is equals to 2. And here, if you observe, all the time, the value that is changing in this particular sequence, pi minus 1, k and j is the j value. So here, if you observe, pk is changing, only pk is changing. Pi minus 1 and pj are same. Okay. So whatever k value that you are taking, so that is coming here for multiplication. Similarly, we'll compute for 2, 5. And here your k value can range from k equals to 2, 3 and 4 because it should be less than j. So this is I value, this is j value. Just substitute in this formula. Only thing that is required is identifying the k value. Okay. So just substitute I value, j value and k value accordingly. That gives you the result. Okay. So this is for k is equals to 2 and this is for k is equals to 3 and this is for k is equals to 4. And these are the values that we are getting. And as I told you, at every time we will be taking the values of these, any values of these m values we will be taking from this particular matrix. After substituting, the minimum value is 1350, which is for k is equals to 2. Okay. So now I got these two values also. Let's update the table. I have updated. Now we are left with one final value, which is M15. Okay. How many k values you will be getting this time? Yes, you are on track. So you will be getting 4 k values, k equal to 1, 2, 3 and 4. So here we have substituted and these are the values. And here if you observe, the minimal value is 1344, which is for k is equals to 2. Now let's update the table. Okay. So I have updated the table and I also have noted down the k values. Why should I take these k values? What is the importance of this k? Okay. What is this table called as is? This table is called as memoization table. Okay. So why we need this table? So in order to remember the values that we have computed in the previous step, instead of computing every time, we take the input of previous step for the next one. So those values are stored in this table. And the k values also we have marked down, right? So now those k values I am taking. So let us see the importance of this. This k value will determine the order of multiplication. So these are our matrices, right? So now let's see what should be the sequence. For multiplication at a time, I can take only 2 matrices. Which 2 should I multiply first? So for that, we will start from here. Okay. So this is the ultimate result. What is the k value that I got here? 2. So that means at 2, I'll make a break. So that means I'll multiply first A1 with A2. So here you can see I'm breaking the sequence A1, A2, 1 and I'm grouping the other 3, A3, A4, A5. So this is the other group. How did I do this? That I did based on this value k is equals to 2. Next, if you observe this row, so one more value. So here you have the next choice I need to take about these 3. So 3 I cannot multiply. So here also again I need to take one more. Okay. So either I can multiply 3 with 4. So where should I break? Okay. So for that breaking, here you have the option. So here you have the k value 4. So the next break will be at 4. So I will be multiplying A3 with A4. Because here if you observe, this is 3, 4. 3, 1, 3, 2, 3, 3, 3, 4 and this is 3, 5. So the third matrix. So the third matrix we are multiplying with the fourth matrix. So you should know which matrix also. So this k is equals to 4 I have got in the third row. So only I am multiplying 3 with 4. Later on here also I have k is equals to 4 but the first entry. So okay. It is A3 with A4. So I will be multiplying A3 with A4 and finally, that result I will be multiplying it with A5. And here if you see the total number of multiplications, after multiplying A1 with A2, okay. So this is the order of A1. and this is the order of A2, right? So the total number of multiplications are 4 into 10 into 3. And then I'm multiplying A3 with A4, right? I'll multiply A3 with A4. So the total number of multiplications are 3 into 12 into 20. After multiplying this, the order of the matrix will be 3 cross 20. That I need to multiply with a matrix of order 20 cross 7. So the total number of here, sorry. Finally, I'm left with 7. So here from the first matrix A1 with A2, the resultant will be 4 cross 3. From the second one, the resultant will be 3 cross 20. And from the third, the resultant will be 3 cross 7. And finally, I'm getting 4 cross 7. So the total cost is 840. Okay, so the minimal number of multiplications that I can make in order to perform this multiplication are 840. And now let's also see the algorithm. And here I'm passing the sequence as an input to this algorithm. And I'm also taking the length -1 for n. Okay, so because I need to have the indexes, the sequence is starting from P0, right? So P0, P1, P2, so on up to P5. So only I'm taking length -1 so that I can start index with 0. And then initially all the I comma i's, I'm initializing it to 0. And then I'm taking, we'll start from the inner loop. Okay, so k is equals to 1 to j minus 1. What am I doing? So this is the same formula that we have used for the recursive calls, m of I comma k plus m of k plus 1 comma j plus p of I minus 1 multiplied with p of k multiplied with p of j. So using this formula, what am I doing? I'm computing the cost, and every time I'm checking is the cost less than m of I comma j. So initially, what am I doing? All the m of I comma j's, I'm initializing it to some maximum value. Okay, so whatever cost I'm getting, if it is less than this maximum value, I'll update the cost, and I will also note down the value of k. Okay, so that I am storing it s of I comma j. The sequence in which I need to multiply also I should know. So for that I am storing my k values also. And here, if you see, I'll just explain one iteration and others you can follow. So here L value is ranging from 2 to n. Why from 2 to n? So here you can see we are starting from the second element. We are not taking the first one because it is a diagonal. This we are not computing. So I'm starting from 2 to n. So 2 to 5 iterations I'm taking. And then I is equals to 1 to n minus L plus 1. Okay. So L is 2. So 5 minus 2 plus 1, which is 4. Okay. So for computing this 1, 5, how many sub formulas we got? I'll just go back one step. So here you can see in order to compute m of 1 comma 5, 1, 2, 3, 4. 4 sub formulas I got. So for that sake is this one. Okay. So this outer loop is for that. And then in the inner loop. So initially I value is 1, j value is 2. And then I will be initializing 1 comma 2 to 0. Sorry, I will be initializing m comma 2 to some maximum value. So you can take any maximum value of your choice. Just initialize it and then you compare. After comparing the cost of 1 comma 2 with this value, we will update. Okay. So this value gets updated. Similarly, you will come out of this loop and then again you start with a fresh value of I. So this time I value is 2, j value is 3. So again m of 2 comma 3. So this is initialized to some maximum value and you will compute that. Okay. So 2, 3 gets calculated. Similarly 3, 4 and then 4, 5. So with that we'll complete one iteration and we increment the L value. Okay. So then you will compute 1, 3, 2, 4 and 3, 5. So then again you will compute 1, 4, 2, 5 and finally we will be with 1, 5. And if you see for calculating the time complexity, so here I have a loop which will be running from 2 to n. Here also I have a loop with I loop which is running from 1 to n minus L plus 1. And inside this I have one more loop which is running from I to j minus 1. Okay. So we never worry about the constant since we have 3 loops. Okay. So let's take it as big O of n cube, n into n. So on average, let's take each loop is running for n times. So it is less only actually. The second loop will run for n minus L plus 1 times, and even the third loop will run even less number of times. But what matters, the value. Always we consider the largest value. The second one can be even less than n minus I minus j it can be. Okay, so but what matters, always we multiply these n's, right? So the complexity is big O of n3. So in exam, if you just write one statement for n3, so you know the time complexity for matrix multiplication, right? So it is big O of n square. So like that, how many times you are performing? So since you have n elements, n times you are performing. So n into big O of n square, which can be big O of n cube. So in this way also you can perform the analysis. Okay, so finally, if you write a statement for time complexity, that is enough. Nobody will ask you to derive the time complexity. Okay, so solve the problem, give this algorithm, and then give the time complexity. In exam, whether they ask or not, it is better to write the algorithm and time complexity based on the number of marks. Hope you liked. If you have any queries, please let me know in the comment section. If you like the video, please do like, share, and subscribe. Thank you.